All right, for page 39, go ahead and label it examples of synthetic division. And so for this first example, we want to take the function f of x and divide it by both x plus 2 and x minus 1. We could use long division to do both of these, but we're going to go ahead and use synthetic division because we do have it of the form of x minus c, our binomial that we're dividing by. So our divisor, it has a coefficient of 1 and it has a exponent of 1. So synthetic division will be a lot easier here. So to start this process off, we're going to write down the coefficients of the polynomial. We must also account for every single value. Even if it's missing, we have to put it 0 in its place. So the highest exponent here is 3, then it goes down to 2, then 1, then 0. So all coefficients are accounted for. So we'll write 2, 1, -5, and 2. And for this first one, in order to long divide by x plus 2, you would set this equal to 0. That value is -2. So I'm going to put a -2 out here on the box to the side. So first thing we're going to do in my synthetic division is bring down that 2. And then once I bring down that 2, I'm going to multiply the -2 by 2 to get -4. I'll add vertically to get -3. I'll start over, multiply by -2 and -3. That gives me 6. Add vertically, I get 1. -2 times 1 is -2. Add vertically, and I get 0. So now that I've gotten 0, I know that this polynomial f of x divided by x plus 2, if I were to use long division, my quotient would be 2x squared minus 3x plus 1. You'll notice I use these coefficients for my quotient. You'll also notice that I went from an x cube exponent in my dividend down to an x squared. I reduced the power by 1 for my quotient. Now, when you get 0 as a remainder, we know that that binomial or that divisor is a factor. And so far we have two factors of f of x, one of which is x plus 2, the other which is 2x squared minus 3x plus 1. And so because I have a remainder of 0 in synthetic division, I can actually continue with these same values in the process, 2, -3, and 1, and I can use them to start the process all over again. Now, by the way, you could also just simply factor 2x squared minus 3x plus 1 as well, since it is a quadratic. You could factor that, and if you were to factor that, you would get the result that I'm getting right now in these last steps for my synthetic division. So let's go ahead and do that first, and then I'll show you the factoring. So if I take x minus 1, which was the previous binomial, x minus 1, if I set that equal to 0, add 1 to both sides, I get 1. And so now that's going to go inside my box on the side. And so I kept those same coefficients 2, -3, and 1, as I said I would do earlier. And so I'll bring down my 2 first. I'll multiply 1 by 2 to get 2. I'll add vertically to get -1, and I'll start the process over again. 1 times -1 is -1, add vertically, and you get 0. So now, I'm again going to take my quotient, I'm going to reduce the power by 1. It began as an x squared. I'm going to turn it into a 1 now. It's the coefficient is going to be 2 here. So we have 2x minus 1. So my last factor that we get for f of x is 2x minus 1. The two they provided were x plus 2 and x minus 1. So if I take these two, I told you earlier that 2x squared minus 3x plus 1, I actually could have just factored from here because it was a quadratic. And if I were to do that, you truly would get 2x minus 1 times x minus 1, which means we could have bypassed this whole synthetic division process. Okay? For example 2, we're going to divide x cubed minus 27 by x minus 3. This is actually one we already did using long division before on our whiteboards, and so we're now going to use synthetic division instead and see what we get. Now, also, just to note, anytime you are missing any terms from your polynomial, you have to account for them. So in this case, you have an x cubed term, but you're missing an x squared, and you're missing an x term both. So in long division, you didn't have to put your zeros if you didn't want to. You could still do the problem. However, for synthetic division, you have to, otherwise you will get the wrong answer. So because I have a couple of terms missing, I'm going to account for those. So as I said, I'm going to put in my 0 for my x squared, and I'm going to put in my 0 for my x. So my coefficients become 1, 0, 0, negative 27. And so when I start this process, I'll bring my 1 down. I'll multiply 3 by 1 to get 3. I'll add vertically. I'll multiply 3 by 3 to get 9. I'll add vertically. And then I'll multiply 3 by 9 to get 27. And again, I'll add vertically. So once I reduce my power by 1, it started with an x cubed. It has now turned into an x squared. So we've got 1x squared plus 3x plus 9 as the coefficients. This is going to be my quotient. So those are the coefficients for my quotient. And so this is going to be my answer for when I'm going to divide. So what that means then is that we're going to have x cubed minus 27 equal to x minus 3 times x squared plus 3x plus 9. Now, you should notice that this is a difference of cubes, x cubed minus 27, because it's a difference of cubes. We could actually use our difference of cubes formula, and this is the exact same answer you would get by just simply factoring using your difference of cubes formula. And then final example, example 3. So now, the question says we are going to find the value of k so that the remainder is 0. And the polynomial that they're going to divide into, the dividend, is 2x cubed plus kx squared plus 7x minus 2. We want to divide that by x minus 2. So we'll start out our synthetic division. And what we want to do is go ahead and bring that 2 down just like we normally would. And then we would start the process. So 2 times 2 is 4. That would go under k. But you're going to notice that you end up at a point where you can't continue because 4 plus k is not going to give you anything to be able to get equal to. So what we'll do is we're actually going to work backwards from here. So we've kind of stalled out at this point, so we're going to work backwards. So negative 2 must have been added to something to get 0. So that's going to be 2. So I'll put a 2 right underneath there. So 2 plus negative 2 is 0. And then this 2 right here had to have a number here so that it became 2. So when you multiply this 2 in the box by 1, we know that that's going to give us 2, and that's going to give us the 2 that we need here to get 0. So far now we have a 2 here, a 1 here. And then what do you add to 7? To get to 1, that number must be negative 6. We're going to have a negative 6 here. And so you'll notice that I'm going to continue work backwards. So in order to get a negative 6 underneath this 7, that means you multiplied here by negative 3. And in order to get this negative 3 down here, remember this was a 4. So far we have k plus 4 equal to negative 3. So if you take k plus 4 equal to negative 3 and you subtract 4 from both sides, you end up with negative 7. So the value of k must have been negative 7 in order for us to get a 0 as our remainder. And that's it for this page.